Okay, so to even give yourself a chance here, you have to know what a critical number is. Sometimes why are you finding it? And that's got to be your start. So critical numbers occur when the first derivative is 0 or undefined. The derivative of sine something would be cosine something. And looks like we need the chain rule here. Okay, with the derivatives part, again, I know I don't spend as much time on that now because you guys have been doing that for a few weeks, but always speak up if I'm going too fast on that piece. Okay, this is never undefined. Cosine's never undefined. If you think about the unit circle, cosine always exists. So the only way you would have critical numbers is if this equaled 0. So set it equal to 0. Divide both sides by -4. You get down to this. And we got to find all of the numbers, or all the angles between 0 and 2 pi times 2 that would give us a cosine of 0. So that's not very easy to do with just guess and check. You could probably get some of them. Actually, if this was a multiple choice question, it might be quicker to just plug in some of the choices and narrow it down to one. But algebraically, what you need to think of is when does cosine equal 0? Okay, so that's unit circle, but that's just x. Ours isn't really x, ours is 2x. So we got to do a little bit more work. So how we would have done this in pre-calculus is instead say the first one's at pi over 2, and then how far do I have to go to get to the next one? Okay, and then after I add pi, I get here, and then how much do I have to add to get to the next one? And so do you see if you just keep adding pi, you just keep getting more solutions? So if you add integer multiples of pi and divide both sides by 2, this is like a formula now that gives you all the solutions. One of them is pi over 4 plus any integer multiple of pi over 2. But we only want answers between 0 and 2 pi, because this, I mean, there's an infinite number of answers here. So the first one should be pi over 4. And then let's add pi over 2. So pi over 4 plus pi over 2. Think like common denominator here. That would be 3 pi over 4. Is 3 pi over 4 between 0 and 2 pi? Okay, then it needs to be an answer. Take 3 pi over 4, add pi over 2 again. That would be 5 pi over 4. Is 5 pi over 4 between 0 and 2 pi? Then that has to be an answer. And this is what I'm worried about. I'm afraid you won't get some of these if you just try guess and check at this point. Add it again. That would be 7 pi over 4. Is that between 0 and 2 pi? Then it's an answer. Add it again. 9 pi over 4. Is that between 0 and 2 pi? Then that's how I know when to stop. And, of course, you can check that part. This is supposed to be a solution to this equation. So if I took 2 times pi over 4, that would be pi over 2, and the cosine of pi over 2 is 0. Or I could plug this one in. 2 times 3 pi over 4 would be 3 pi over 2. The cosine at 3 pi over 2 is 0. Plug in 5 pi over 4, multiply it by 2. Cosine of 5 pi over 2 would also be 0. So you can plug them all in to check.
I'm kind of confused how you got the pi over 2 plus n pi.
So this was the first solution. The first answer was at pi over 2. And then I saw if you added pi to that, if you add 1 pi, you get 3 pi over 2. So that was another solution. If you add pi again, you get 5 pi over 2, and then you could add that again and get another one, and add that again and get another one. And you can do that forever. So this formula is a way to say the same thing. Pi over 2 is the first one, plus if you take any integer multiple of pi, so add 1 pi, or add 2 pi's, or add 3 pi's, or add 4 pi's, you would get solutions there. So to me, that's easier. To write out the formula, that's how you should have done it in pre-calculus. So, but again, honestly, if this was multiple choice, at this point, even though I can do this, it's probably faster to just plug them in here. If you see pi over 4s in some of the choices, plug it in, see if it works. If it doesn't, you eliminated some. If it does, then keep going. It doesn't hurt to review the mathematics.